Hello everybody, Namaste, welcome to my YouTube channel Ekagrum, and this video is learning material of compulsory science for grade 10 students, and the matters in this video related with the first unit course of compulsory science. Before starting the lesson, let us see some video clips from YouTube. Here we go with the solar systems. Let us see here. Look at here, Earth revolving around the sun. It is a Venus, Mars, Jupiter. Okay, all these celestial bodies revolving around the. Look at it. Now we have another video about the tides. Look at this water waves, the tides from it created from tides. Look at here, high tides. Look at the tides that rises in the sea. Okay, now we go to our subject matters. Okay, you have seen the solar systems, how the planets revolve around the sun, and the high tides rises in the sea in video clips. So how it is possible? We discuss about that in the next slide. Let us look at some solar families member: Sun, Venus, Mercury, Earth, Mars, Jupiter. As you have seen in the video clips. And look at here, these planets revolve around the sun. What force caused them to revolve around them? Look at here. There is a force called gravitation. Okay, this is the effect of gravitations. And what is gravitations? It is a mutual force of attractions between these objects: Sun and Mars, Sun and Venus, Mercury and Sun, Earth and Sun, and similarly the mutual force of attractions exists between Earth and Jupiter and other planets too. Okay, so this most mutual force of attractions cause them to revolve around the sun. So Newton had discovered that everybody in this universe attract each other towards their center. So such force of attraction is called gravitation or gravitational force. Okay, look at here. There are also the sun, earth, moon. The sun is, and it is earth, moon. Now we define the gravitations. Okay. Now the definition of gravitation: the mutual force of attractions between any two bodies in the universe is called gravitations. Look at this. The gravitation is also known as gravitational force, and the gravitational force is denoted by F. It is a force, and the unit of gravitational force is Newton. Okay, and next, now the consequences of the gravitation or gravitational force. The planets revolve around the sun, the tides rise in the sea, and the moon revolve around the earth, and so many other things. Okay, the objects from in the sky come back to the surface. That is also the gravitations, but the object is comparatively very small to the planets, so do not observe like in solar systems. Okay, so this is the concept that we learned in these sessions. Now next we have some law, Newton's universal law of gravitation. The gravitational force of attraction between any two bodies is directly proportional to the product of their masses and inversely proportional to the square of the distance between their center. This is the most common and important law of gravitation derived by Newton's. Okay, so directly proportional to the product of their mass and inversely proportional to the square of the distance between their center. So the force of attractions that exists between any two bodies is directly proportional to the product of their mass and inversely proportional to the square of the distance between their center. Next we have mathematically, this can be expressed as, if here be a force of gravitation produced between two masses m1 and m2 kept at a distance, then distance d, then 1 f varies m1 times m2 and f varies 1 upon d square. That means f is directly proportional to the product of two masses and inversely proportional to the square of the distance between their center. Next, the meaning of this directly proportional. Okay, the value of f increases when the masses of the two bodies increases, and the value of f, that is gravitation, decreases when the masses of two bodies decreases. So there is a direct relationship. So the gravity of gravitation is directly proportional to the product of the masses of the two bodies. The meaning of f varies m1 times m2 means, if one quantity, if these two quantities are increased, then f is also increased, and if the two quantity decreases, then f also decreases. Now we have another relation, that is f is indirectly proportional or inversely proportional to the square of the distance. So it means, if the distance of the two bodies increases, then the force of gravitation decreases, and if the distance of the two bodies decreases, then the force of gravitation increases, and this is the inverse relationships. Okay, so the force of gravitation F is inversely proportional to the square of the distance d between their center. Okay, and now we have some questions of these clips. Look at here, first questions, set of questions. You copy these questions and answer it, and you can submit it, inbox me in my messenger. Okay, what is gravitation? What is the SI unit of gravitational force? Write any two effects of force of gravitation. The answer is very easy one, try it. Okay, and next set of question is, look at these questions. State the Newton's law of gravitation. You state the Newton's law. You can write this one for the Newton's law, or this one. Okay, for the Newton's law of gravitation. Next, we have another question. Write the relationship between the force of gravitation F and this. This means F is directly proportional to the m1 times m2. And another relation that we can write between the F and D is F is inversely proportional to the 1 by d square, that is square of distance. So we can write this in symbol. Look at here, and this can be written as F rise m1 into m2. Okay, F rise m1 into m2. You can copy this, C, and you go to this one here. F rise m1 times m2. Okay, let's make it 1 m2. Yes. So the relation between the F and the m1 and m2 can be written as like this. And similarly, in these relations, we can write that F varies 1 by square of d square. Okay, you can write that. So close d square. F varies 1 by d square. This is the answer for this third questions. Okay. Okay, now we go to the next slide. That is a formula. How to calculate the force of gravitation or gravitational force between two bodies. We have a formula F equal to G times m1 times m2 whole divided by square of the distance between the two bodies. Look at these diagrams. This is a body. Okay. And the mass is m1 and another body is this blue one, and this is mass is m2, and the distance between the center is d, and the force, there is a mutual force of attraction between these two bodies. Okay, this is denoted by F. And how we calculate it? F is a force of gravitation between these two bodies. Okay, and they are mutuals and equal also, and the two mass, because of due to these two mass, the force exists or the gravitation force exists when they are kept at the distance, and this force can be calculated by using this formula. Look at here, this formula, you can see that F equal to G times m1 times m2 whole divided by d square. This is the most important formula of law of gravitations. Okay, now we derive this formula. Look at this formula. Okay, let n be two bodies with the masses m1 and m2 respectively, and let d be the distance between their centers. Just like this diagrams, you see two masses A and B with masses m1 and m2, and the distance between them is d. Okay, now look at here. The force of gravitation is produced between the two masses due to their masses, and let the force of gravitation be F. Then by Newton's universal law of gravity, we have that F is directly proportional to the product of the mass m1 and m2 and inversely proportional to the square of the distance d. Okay, so combining these two relations, we get F varies m1 m2 whole divided by d square, and this quantity, now this sign of variations is changed to equality by multiplying this quantity by g, capital G, where G is the universal gravitational constant. Okay, and this formula is called the formula of Newton's law of gravitation, and this is the most important formula to calculate the gravitations. You can see here, this is the formula. Okay, so we have derived this formula, and this derivations is useful and important also. Now we have another concept, that is universal gravitational constant G. Okay, this is denoted by capital C. Okay, and look at this. What is this universal gravitational constant? So look at these diagrams. You see the two masses m1 and m2, both are of 1 kg. Okay, and they are kept at a distance of 1 meter. So the gravitational force produced between the two unit mass kept at 1 meter distance apart. is known as gravitational constant. And why it is called gravitational constants? It is always same. The value of that force is always same. This value is always same in everywhere in the universe. It is not affected by temperature, okay, and nature of the object, mass, okay, nature of the matter of the mass, the force, the attractions that produce between two unit masses when they kept at 1 meter distance apart. It's known as the universal gravitational constant, and it is called constant because it is same in everywhere in this universe. Okay, they are not affected by temperature, their shape, size, okay, and the matter contained in the substance. Okay, now look at these definitions. The gravitational force produced between two objects, each of unit mass, kept at unit distance apart from their center, is called universal gravitational constant G, capital G. Okay, and now look at it. The value of the universal gravitational constant is 6.67 times 10 to the power minus 11 Newton meter square per kg square, or kg minus 2 power. Okay, and it is same everywhere in the universe. This value is constant. This value is same in everywhere in the universe. Okay, and the force of gravitation F and gravitational force, the constant G, are equal if m1 is equal to 1 kg, m2 is equal to 1 kg, and d equal to 1. And this is derived from the formula, you know, this one. If we put m1 equal to 1, m2 equal to 1, and d equal to 1, then the result is F equal to G. So the force of gravitation equal to the value of gravitational constant when these quantities are unit. Okay, so now we have another slide. Now we calculate the force of gravitation produced between the two bodies of mass 20 kg and 50 kg if the distance between their center is 2 meters. So first of all, we write the given informations here. The m1, you know, m1 is equal to how much is that? 20 kg, and m2 is equal to, it is 50 kg. Okay, and next we have given the distance d. D is equal to 2 meters, and also we know the value of z, that is gravitational constant. It is 6.67 times 10 to the power, you know, minus, you can write minus power for this symbol, minus 11. Okay, and the unit is, you copy it from here. Okay, what is the one? Control C. Okay, next slides. Okay, we have this, Control V, meter square per kg square. Okay, this m must be small one. Okay, this m must be small m, meter square, and this is the given information, and you should write this one. This value should be written. Okay, now we have a formula. Okay, now we have to find F equal to what? Okay, so we have a formula that you can copy it from the previous videos. This one. Okay, see. Okay, now we have here B. So putting the respective values, you get that the value of Z, you know, the value of Z is 6.67. Copy it. The value of Z is, okay, you put the bracket here, and times 20, no, 20 times another is 50 bracket. So substitute the value of all given quantities and distance is 2 meters. Okay, that is 2 square. Square of 2 is, you can write that 2 square. Okay, you can write this in another steps. Okay, this one. Okay, that is 2 equal to. Okay, so I'm calculating this all using calculator. You can calculate the values. Okay, calculating these quantities. Listen, 6.67 times and 20 times and another quantity is 50. Okay, 50, and this equals, look at it, 6670. Okay, 6670. Okay, you have that 6670. The value is 667 into 10 to the power minus 11. Okay, and the whole quantity is divided by 4. Square of 2 is 4. Okay, and when it is divided by 4, then you will get equal to okay, let's use calculator. Yes, this is divided by 4 equals 1667. 1667.5 into 10 to the power minus 11, and it is a force, so Newton. This is the value of force of gravitation that produced between, very small, this is a minus 11, sorry, I forgot to write here minus, and this is also the minus 11, power is minus 11, 10 to the power. This is the symbol of power. You can by using scientific calculator you can find it in another word, and this can be written as 1.667 10 to the power, into 10 to the power is minus 8 Newton. Okay, this is the solution of this Newton. Okay, this is the solution of this numerical problem. So in this way, first we write the given informations, and this should be written always, and use this formula, you'll get the value. Okay, and this is the value of force of gravitation that produced between the two masses, each of 20 kg and 50 kg, when they are kept in 2 meter distance apart. Okay, and more precisely you can write in copy, in place of this power you can write 10 raised to the power minus 8, 10 raised to the power minus 11, 10 raised to the power minus 11. Okay, don't forget the symbols. Okay, now we have another slide, that is the factors affecting the gravitational force. Okay, the gravitational force is affected by the masses. Okay, G is constant, and the product of two mass and the distance between the two centers. Okay, these two factors, mass and the distance, are the factors that affect the gravitational force that produce between the two masses. Now we have some exercise for you. I copy all these questions, okay, and answer it, and copy all these lessons are taught in class 10, and this is from first unit, force of compulsory science, and this is the learning materials for you during this lockdown period. I hope you see this video and try these questions. Okay, so try to solve these questions. First question, define gravitation constant. We have already seen that. Look at here, the gravitation constant, you can answer it. And next, write the value of G, same. Okay, you can see this. Write the formula of universal gravitation's law, and we have here the another questions. Okay, see, if x and y are two bodies, unit mass kept at a unit distance, then find the force of gravitation between two bodies. And in this case, F is equal to G. The value of G is, look at here, 6.67 into 10 to the power minus 11. This, you just write the unit is Newton. Okay, because we have to write and the force of gravitations. Okay, next. Now, if the two objects of mass x and y k z are kept at a distance of z meter, and from the center, if the force of gravitation between them is F Newton, then write the relation between them. And the relation between them is very simple one. You can write here. Okay, F equal to you can write F equal to G times, okay, x times y times all divided by z square. Okay, z square, you can write z square like this. This is the formula. Okay, this is the answer of this question C. Look at here. F equal to G times x times whole divided by z square. Now these two questions, F and G, it is similar to this part, this one. Write M1, M2, distance between these, it is a small d, sorry, okay, small d, okay, small d, distance between them, and write G and find F. Write this formula and solve, okay, for this F and G. And the answer is given here. You try at home. Okay, I hope you enjoy this video, and this video is helpful to new grade 10 students as well as SEE preparing students during this lockdown period. Thank you for watching the video.